All right, 2.6. So the screen. Nice. Okay, what you see up here is called a flow chart, and it's not any different than a two-column proof. It's just written in a way that has boxes around your statements, and the lines underneath are your reasons. Okay, and you have to draw an arrow from one box to the next. All that is just like when I drew arrows on your two-column proofs. You're just saying, hey, this is my train of thought. This is where you need to go from here. Okay, it's just a different way of writing a two-column proof. Nothing different about how you solve the problem. You'll also have a paragraph proof. All that is, instead of writing a two-column proof, you're writing everything down in sentence form, which that's a no-brainer. That's kind of what you're saying when you're thinking through the things, using the actual statements and also your postulates and definitions. You just have to write them down in sentence form. But almost always, not always, but almost always, we'll have you do a two-column proof. Okay, so let's go through this flow chart that's here, and you see that they have 4 possible answers at the bottom for you. That's awful nice of them. That's not going to happen for you on your test. So you have AC is equal to AB plus AB. All right, so this is very similar to what we did the other day, so we're just using this as an example. So what goes in that blank? AC equals AB plus AB. The given. All right, so you're going to write given in that position. All right, and then we have AB plus BC. So we have AB plus BC, and that equals AC, the whole thing. So what do we call that? Based on the answers you have to choose from. What are we doing? Segment addition postulate. Okay? You're adding 2 segments together to get a bigger segment, right? So you say segment addition postulate. Now notice you have the given and that statement with arrows coming from them to the very next thing. So those 2 things together, we have AB plus AB, which happens to be that one there. And then it's equal to AB plus BC, this one here. Now, if you didn't have these given choices down at the bottom, you might look at what I just circled and say, oh, this next point needs to be AC equals AC. That's the transitive property, except that's not what it says. It says AB plus AB is equal to AB plus BC. Okay? So since it doesn't say AC equals AC, you might be thinking, oh, well then this can't be the transitive property. But what is it that we're actually doing? Because AC is equal to AC, you therefore have those other 2 things. And yes, it is the transitive property. So you can get confused on what's being said in the previous stuff. I'm hoping everybody actually guessed that that was the transitive property. Is that true? Okay, good. One of you. All right, that's excellent. All right, so now we have the proof statement. AB is equal to BC. And the only thing left is subtraction property. So what did we subtract? We subtracted one of the ABs, didn't we? We subtracted an AB from both sides. So that left the AB equal to the BC. So subtraction property. All right, so it's not any different than your 2-column proof. You just write it as a flow chart. All right, let's go to the next one. So this is just needing to go over your vocabulary that you have to know. I'm not going to make you write theorem or postulate at the end of everything. So if you say right angles congruence, I'll accept it. You don't have to have the theorem. But not all teachers are like that, okay? So you need to know what right angles congruence theorem is. It just means that all right angles are congruent to each other. And you might be sitting there thinking, well, duh, that makes sense. Yeah, but you no longer have to prove that they are congruent to each other. If you have two right angles, you can just say they are congruent because of the right angles congruence theorem. Okay? Yes? Again, as you start to do more proofs, you'll see that these things help shorten all the things you need to say. Congruent supplements theorem. Now, this is important because this is something you've not had before. So this just says if two angles are congruent to the same angle, or excuse me, if two angles are supplementary to the same angle, then the two angles must be congruent to each other. So here's what it says. Look at the picture. If angle 1, let's say angle 1 is 40 degrees. Then, and angle 1 and angle 2 are supplementary. So what does angle 2 have to be if they're supplementary? 140. So we're just using numbers to help us see what this is saying. But it also says that angle 2 and angle 3 are supplementary. So if angle 2 is 140, what does angle 3 have to be? 40. Because they have to add up to 180. And as you notice, then angle 1 and angle 3 are congruent. So let's reread what this is saying. It's saying that if you have two angles, angle 1 and angle 3, if those two angles are supplementary to the same angle, angle 2, then angle 1 and angle 3 must be equal to each other. That's what that's saying. So we call that the congruent supplements theorem. Because before you have to prove all of that stuff. Okay, let's go to the next one. Same thing with congruent complements theorem. So if you have two angles, angle 4 and 6 are complementary to the same angle. Notice they don't have to be attached. Supplementary and complementary angles don't have to be attached. Linear pairs have to be attached. All right, so let's say angle 4 is, we'll say 40 again, and angle 6 is 40. And they're both complementary to angle 5. What does angle 5 have to be? 50. Complementary means they add up to 50. So if angle 4 is complementary with angle 5, and angle 6 is complementary to angle 5, then angle 4 and angle 6 have to be the same thing. It's easier to see on the supplementary one, not on this one. Everybody okay? Don't worry. Half the assignment isn't like this. Now let's go to postulate 2.8, linear pair postulate. This is the same thing as we've been saying. We've just been saying the definition of linear pair. So if angle 1 and angle 2 form a linear pair, angle 1 and angle 2 are supplementary, and they add up to 180 degrees. That's all that means. We already knew this. We just had to actually say all of those statements. Well, now you have the linear pair postulate, and all that stuff is understood. Seems kind of silly, but it'll help on your proofs, which means on your proofs today, make sure you have the list of these things close at hand, because that's what they're wanting you to use. Little hint for you in all your books. Usually all the problems are going to be asking specifically about the things you learned in that section. Okay? Unfortunately, with proofs, you still need to remember all the other statements, okay? All right, and the last thing here before we get to the last page is the vertical angles theorem. There's nothing new there other than it's a theorem now. We understood what the definition of vertical angles were. It's just now it's a theorem. So Opposite angles are congruent and equal to each other. All right, let's take a look in your book at, let's see here. Let's look at number 4. It says identify the pair of congruent angles in the figures. Explain how you know they're congruent. Okay, so number 4. You don't have to open it up yet. Just look up on the screen here. Look at number 4 there. What angles are congruent? Name the angles. Chapin.
Angle GF.
Angles have 3 letters, so which angle are you talking about? Number 4 is what we're talking about. The one right in the middle. Okay, so angle FGH is congruent to angle WXZ, not JKM. And not either any of the little angles. None of those are the same measurements. Okay. First of all, JKM is 89 degrees, not 90. On FGH, we have 90-degree symbol. And WXZ, 58 and 32, equals 90. So those are complementary. So this is just about identifying what angles are the same. So how do we know those two are the same? Because they both equal 90 degrees. Okay. Angle addition postulate for WXZ. Okay. So make sure you're looking at your answers in the back of the book as you're doing this, so you can kind of catch on how to correctly say these things, other than just saying, oh, they equal 90 degrees. Okay. All right. So the last one I want to show you is number 14. What do you think we need to do here? Algebra. And what algebra are you going to do and why? The instructions are find the values of x and y. What is it you notice about this picture? Yes?
Just add the bottom and the top and the sides.
We're not adding. What theorem did we just learn that this picture is all about? Vertical angle theorem. What do you know about vertical angles? What? They're congruent. They're equal to each other. Okay, so I'll just do part of this, okay? And I want to give you a heads up because let's do the top and the bottom here. We have 2 times 5x minus 5. And we're going to set that equal to 6x plus 50. On some of these problems, and we're going to do this for quite a while here, they're going to put an x on one side and a y on the other. And you can't solve that. But the other 2 are only going to have one of the variables, and you'll be able to solve that one. So you, not only do you have to know what to do, but you have to understand what should I do first. On this one, you could do either one of these vertical angles. Okay, you could do left and right, 5y plus 5 equals 7y minus 9, and solve for y. And you got to do that anyway to solve for y, but we're just going to solve for x here just to make sure we can do it right. What should I do at this point to solve this? Everybody? Distribute. So we get 10x minus 10 equals 6x plus 50.
Are you still doing proofs on this? Or just solve?
What?
Proofs on the side?
No, it didn't say explain, so. Now what? Subtract 6x, and we get 4x minus 10 equals 50. Add 10, and we'll get 4x equals 60. Divide by x, and how many things go into 60 4 different times on a clock? What goes into 60 4 times? 15, right? 15 and 15 and 15 and 15 mixed. Okay, so that's a simple way to remember 60 divided by 4 is 15. Okay, now that's just what x is. It says find the values of x and y. Notice it didn't say find the measurement of the angles. Please read your instructions. All right? So we found x. Now you'd actually have to do that for the other set to get y. Is everybody okay with what you're doing? All right. So your assignment is on Google Classroom. Get at it.